guys, this is Professor Janacek. I want to do an example where we find the volume of a solid of revolution. Remember that volume in this situation will be considered as area times thickness. So let's determine the volume of the solid obtained by rotating the region bounded by y equal to x squared minus 2x and y equal to x about the line y equal to 4. Well, I've already graphed these. As you can see, y equal to x squared minus 2x. That is this parabola here. And of course, that parabola does extend a bit further, but when I look at the line y equal to x, this diagonal, I recognize where they intersect, and so I only need this little bit in here. By the way, in graphing these, I was able to come up with the points of intersection. It was kind of nice to get those. Worked out really well. We'll actually end up using those values, so make sure you can identify those points. Okay, now we are revolving about this line y equal to 4, a horizontal line up there. So when we rotate this this little figure down here about that, you'll see what we get. It kind of has this funky bowl shape. So the whole thing would be kind of this big bowl-like piece, right? That's what the whole shape looks like. But if you look inside of it, it has this funnel shape that's empty. So this little funnel inside is open. So we want to find the volume of that solid. Okay, I have already selected a little piece to analyze. This little piece here, I chose a vertical piece because this looks a little longer in the vertical direction than in the horizontal direction. And if the integration ends up being difficult, then we can always come back, start over, and try analyzing a horizontal piece. So let's see. We are revolving about the line y equal to 4. Well, y equal to 4 is a horizontal line, so you can kind of think of it as being like the x-axis. It's going to help us when analyzing the notes above. All right, let's see. Now, if we look at this piece here that we've selected, that piece is actually perpendicular to that line. Y equal to 4, and again that y equal to 4 is kind of like an x-axis, like the x-axis. And so looking now at the notes, revolving about something that's like the x-axis and perpendicular to something that's like the x-axis, it looks like we are going to integrate with respect to x and use the formula a equal to pi r squared. So our volume, again, that's area times thickness. Remember, the thickness is our differential. In this case, we are integrating with respect to x, so we'll write that as dx. And so we end up with pi r squared dx is what we're looking at. Now we do need to kind of contemplate this radius for a bit. What is the radius of the circle? Now this gets a little tricky because I'm not going about an axis, I'm going about this other line. So let's take a look. How can we write out this radius? Well, looking at the circles, so if I take this big circle here, that's the direction of my circles. Of course, I've got several circles. If I look at, say, a circle kind of somewhere here in the middle, you'll notice that the radius goes from the line y equal to 4 all the way down to my parabola. That's the outer radius. There is also an inner circle here, the part that we're getting rid of, the part that's empty, and that has a radius that goes from the line y equal to 4 down to the line y equal to x. So this means my radius, the outer radius, was, again, taking a look at that one, the outer radius, there's an outer circle. The radius goes from y equal to 4 out to the parabola. So we'll write that as 4 minus x squared minus 2x. That's the outer one. We'll subtract off the inner one. The inner circles, the part that we're getting rid of, that we're subtracting off, has a radius that goes from y equal to 4 to y equal to x. So we'll write that as 4 minus x. So that's how we're going to think about the radius in this situation. So, okay. Let's see if we can put some numbers in here and get to this integration. We are integrating, again, with respect to x. So our x values go from, this is where remembering those points of intersection will help, goes from 0 all the way out to an x value of 3. So those are limits of those are the limits of integration. Then we have pi times r squared. Now we've already determined our radius, but we do need to square those, so we'll square them first before subtracting. Take a look at my video on using the ring washer method, which, by the way, that's what this is. We're using the ring or washer method here. And so we end up taking 4 minus x squared minus 2x, quantity squared, minus 4 minus x, quantity squared, because we have to square that radius. So we square them and then we subtract. Okay, let's see. We can clean this up a wee bit. Distribute that negative. We have 4 minus x squared plus 2x, parentheses squared, minus 4 minus x squared. In the integrand. So now what we're going to need to do is we're going to have to multiply out these polynomials. We're going to take 4 minus x squared plus 2x and square it, which means you'll want to take a moment, write it out twice, multiply, 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 do all that multiplication, combine like terms, see what you get. Take a moment, do that. I don't mind waiting. While you're at it, you can also take the other piece, 4 minus x, parentheses squared. Take that one, again, write it out twice, multiply, 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 combine like terms, see what you get. Then you'll want to take those two and subtract them. Again, combine like terms, distribute the negative, combine like terms, see what you get. Take your time with all that. Again, pause if you need, that's okay. Once you do all of that, you should end up with 24x minus 5x squared minus 4x cubed plus x to the fourth. Again, don't take my word for it. Take the time, do that algebra. Fun, right? Okay, but once we get there, look at that. It's a polynomial. Ah, love integrating polynomials. Those are so simple. So when we integrate 24x, that gives us 12x. Integrate 5x squared, we get 5x, well, actually I'll write it as 5/3 x cubed. Integrate 4x cubed gives us just x to the fourth. And integrating x to the fourth, we get 1/5 x to the fifth. Watch those positives and negatives in there. We are integrating from 0 to 3, so we'll have to evaluate that. And let's see, what do we have here? Okay. Evaluating at 3, evaluating at 0. Evaluating at 0, always nice. Oh, made a mistake there. Let's see. Hold on, that's supposed to be squared, which makes that one a 9. Oh dear, dear, dear. There we go, much better. Woo. So we have 108 minus 45 minus 81 plus 243 over 5. Of course, all of this is minus 0. Oh, let's see, we'll have to do a little bit of arithmetic here. Take a moment, take some time, go through all that. You should end up with 153 pi over 5. Now remember, this is a volume. If we had units, it would be those units cubed. Of course, we don't have any units, so that's it. Enjoy!